Okay, so we're working on the examples from the titration lecture. So if you didn't take a look at the titration lecture notes, make sure you work through them. And then we're working on the very last slide. There's two different examples that I'm going to work with you right now on. You'll notice I made a mistake writing out the first one, but you know what? I'm saving the environment. I didn't want to use another sheet of paper. So that's right. You're welcome, Earth. If you take a look at our first example, it tells us that during a titration, 75.8 milliliters of 0.100 molarity standard solution of HCl is titrated with 100.0 milliliters of NaOH solution. What is the concentration of the NaOH solution? All right, it's probably been a while since you've done a titration question. So let's just remind ourselves that a titration is nothing more than stoich. So we need to remember our 4 steps of stoichiometry so that we can do this properly. Step number 1. Whenever we're doing stoichiometry, your very first step always needs to be a balanced equation. So if we are doing this example, we have HCl reacting with NaOH. So HCl is going to be aqueous, it's an acid. It's reacting with NaOH, also aqueous. This is a double replacement, single way arrow. This is not an equilibrium reaction. This is a neutralization, which means water is going to be one of the products, and it's a liquid. Water is never aqueous. You can't dissolve water in water. It's ridiculous. And then we produce our salt, and in this case, that salt is just the ions that are left over combined together. Happens to be HCl in this one. Okay, that is step number 1. Step number 1 is write a balanced equation. I should point out, this is actually already balanced. 1Cl, 1Cl, 1 Na, 1 Na. 2 H's, 2 H's, 1 O. We're good, we're balanced. It's all 1-to-1 ratios. So what's my next step? Well, my next step is go to moles. So let's look at the information we were given. And the information that I was given is that I had 75.8 milliliters, 0.100 molarity HCl. So 0.100 molarity HCl, 75.8 milliliters. Here's what I'm also going to do. I'm going to convert that into liters. I'm going to go 0.0758 liters. What am I trying to solve? I'm trying to solve the concentration of sodium hydroxide. Now, our next step is to go to moles. So let's do that. To find the moles, we need the molarity formula. Remember, it's moles divided by liters, but we're going to rearrange it to solve for moles. So molarity multiplied by liters. That's why I converted it to liters here. I knew what was coming up ahead. If you didn't see that, just remember to do it once you plug the numbers in. And that's where we're at. We're going to plug our numbers in. So 0.100 molarity multiplied by 0.0758 liters. Okay, how many moles is that? Well, that should be 0.00758 moles. And let's keep in mind what substance we're talking about. We're talking about HCl. That was step 2. That was go to moles. Step 3, after we've balanced our equation, after we've converted the information we have into moles, the next step is your molar ratio. Okay, so here's what I'm going to do. I'm going to take moles of HCl, convert it into moles of sodium hydroxide. So I have 0.00758 moles of HCl. Okay, I didn't leave myself a lot of space here, so we're going to scrunch this in. there is 1 mole of sodium hydroxide for every 1 mole of HCl, right? It's a 1-to-1 ratio. So the amount of moles of sodium hydroxide, well, it's exactly the same. 0.00758 moles of sodium hydroxide. That was step number 3. So we have one last step left. Last step, go where the question asks. This question is asking for concentration. So after we have finished step number 3, our last thing is to do step number 4, and that is to convert moles into molarity. So the molarity of NaOH is going to be the moles of NaOH divided by the liters of NaOH. Here's the other thing we know. We know milliliters of NaOH. So I'm just going to convert this straight away. This is 0.1000 liters of NaOH. So my molarity is actually going to be 0.00758 moles of sodium hydroxide divided by 0.1000 liters of sodium hydroxide. What's my molarity going to be? Well, my molarity is going to be 0.0758 molarity. That's my concentration of sodium hydroxide. Now, hopefully this isn't like a huge shock to your system, because really we're just doing stoic, right? We're doing stoichiometry. We're not doing anything really new. In fact, after completing equilibrium, looking at a titration problem is hopefully almost like relaxing at this point. So let's work through one more example. We're going to do the same exact steps. We're going to go balanced equation, go to moles, molar ratio, go where the question asks. So we have a 20.0 milliliter solution of strontium hydroxide. So let's write that out. Strontium hydroxide is going to be aqueous. It's going to react with HCl. Also aqueous. That's going to turn into, now you need to solve this part on your own. This is not something you get from reading the question. Remember, H and OH are going to combine to make H2O as a liquid. The other thing is the salt, and it's going to be made out of the leftover ions. So it's going to be SrCl2. Sr has a positive 2 charge. Cl has a negative 1 charge. You need 2 Cl's to balance that positive 2 for the SrCl. That's an aqueous substance, and now we need to balance. So I have 2 Cl's. I need 2 Cl's over here. Gives me 2 H's. I have 2 H's over here. I also have 2 more H's over here. So I actually have 4 H's, 2 O's. So I need 2 waters. These are just ones, and that's my balanced equation. Now, the other thing I like to do is write out my information. So I have 20 milliliters. We know, since we're dealing with the molarity formula, we're going to need that in liters. We also are trying to find the concentration of this substance. But we know that we have 25 milliliters, 0.0250 liters of HCl. And we also know, because it's our standard solution, one with a precisely known concentration, the HCl, we know that concentration. So that's step 1, balanced equation. I sorted out the information that I have. Let's do the rest. The next step is go to moles. So using my molarity formula, rearranging to solve for moles. Moles is molarity multiplied by liters. So for the HCl, it's going to be 0.0 molarity, right? The number that, oh, sorry, that's liters, my bad, multiplied by the molarity, 0.0500 molarity. Okay, so now we solve what that is. The number of moles of HCl is 1.25 times 10 to the minus 3 moles. Now, I'm going to write the substance with it because I don't want to forget what I'm actually working with. I know my moles here are 1.25. Okay, we did step 1 right here. We balanced our equation. We did step 2 right here. We've gone to moles. Let's do step 3 over here. Let's use our molar ratio. So I have 1.25 times 10 to the minus 3 moles of HCl. I'm going to convert this into moles of strontium hydroxide. Ooh, almost wrote chloride. From moles of HCl. Now, use your molar ratio here. There's 1 mole of SrOH2 for every 2 moles of HCl. So what do we get? Well, we get 6.25 times 10 to the minus 4 moles of strontium hydroxide. That was step number 3. Step number 4 is go where the question asks, and the question asks for molarity. Molarity is moles divided by liters. So it's going to be 6.25 multiplied by 10 to the minus 4 moles divided by my number of liters for strontium hydroxide, 0.0200 liters. All right, here's what we find. The molarity, 0.03125 molarity. But we can't forget sig figs. We can never forget sig figs. So how many significant figures? Well, I had 3 in this number, 3 in this number, 3 in this number. All I did was multiply. I need to keep 3 in my final answer. Oh, I forgot a 0 here, sorry. So 0.03125. When we round that to 3 sig figs, we get 0.0313. Like I said, this is just stoichiometry. And as long as you remember your 4 steps of stoichiometry, balanced equation, go to moles, molar ratio, go where the question asks, this will work every time. Biggest mistake people make, they see the question and they read through it, they go, okay, milliliters, molarity, milliliters, concentration, okay, I have an M, V, M, need to find a V. They use M1V1 equals M2V2, and then they get the question wrong. Don't use M1V1 equals M2V2. If you read the words like titrated, if you read things like neutralized, any sense that there's a chemical reaction going on, you can't use the dilution equation. You have to use stoichiometry. So please make sure when you're dealing with a titration that you're using stoichiometry, and this will work out for you every time. Okay? Again, go do practice. I know it seems easy. I know you think, okay, I don't need to practice this. I know how to do stoic. Trust me. Go practice this, work through these assignments, check your answers, see how it goes. And that is acids and bases. Good luck.